Thank goodness we're at the last little bit of this last section here. We have 3 more examples. And this is called rationalizing the denominator. Let's see if I can find my example here. All right. So if you notice here, I have a fraction under the radical. We've had this before. We've done problems where we had a square root, but this time it's a fourth root. So we have to think about this. I'm going to go back to one that we already know how to do. Something like, so we'll leave this one for a minute. And let's say we had like the square root of 2/3. We would split that up into the square root of 2 over the square root of 3. And then the way we would get the square root off the bottom is by multiplying by the big one. And we always wanted to choose wisely on what we want our big one to be. It could be any number over itself. But in this particular case, we chose the square root of 3 because we knew that the square root of 3 times the square root of 3 is the square root of 9, which is just 3. So our answer was the square root of 6 over 3. So let's go back to this problem I just had. And let's split it apart to the fourth root of 2 over the fourth root of 3. I know that I want to get rid of the radical in the denominator. So I'm going to multiply by the big one, the well-chosen one. I'm going to pick something over itself that would get rid of a fourth root. What undoes a fourth root is by having something to the fourth power. So, for instance, if I had the fourth root of 3 to the fourth power, that would just be 3. So, right now, I just have 1 3 under here. But I need 4 3's under here. So my well-chosen one is going to be the fourth root of 3 to the third power. And I'll show you why. Because now when I multiply, I'm going to have the fourth root of 3 to the fourth power, which is just 3. And now I don't have a radical on the bottom anymore. On the top now, I have the fourth root of, and I can put them under the same radical because they're the same. I don't have 4 of anything under here, so I'm going to multiply them together. This is 27 times 2, which is 54. So my answer would be the fourth root of 54 over 3. Let's do another one of these. I have 2 more examples. The third root of 3/5. So I'm going to start by splitting it up into the cube root of 3 over the cube root of 5. So now my problem is I shouldn't have a radical in the denominator. Since this is a cube, that means I wish I had something cube under here. So when I pick my well-chosen one, this time I'm going to pick the cube root. And since I have 1 5 here, I need 2 more. So I'm going to put 5 squared here. Because now, and a lot of you will skip this step, I'll have the cube root of 5 cubed, which is just 5. On the top, I'll have the cube root of 3 times 5 squared, and that's 25 times 3, which is 75. The last example we'll do together. The fifth root of 3/4. This one's a little more difficult because if you notice on my other examples, these were both prime numbers. So it's easy for me to pick the well-chosen one. So what I'm going to do first is factor each of these. So this is the fifth root of 3 over the fifth root of 2 squared. Because 4 is 2 times 2. I didn't have to do that on the other one because 5 and 3 didn't factor. Now I'm going to try to pick my well-chosen one. And this time I want it to be a fifth root because I'm trying to get rid of a fifth root on the bottom. I have 2 2's already, so if I want to cancel out with the fifth root, I need 3 more, so that now I have 5. So on the bottom I just have 2. And on the top I have the fifth root of 3 times 2 times 2 times 2, which is 8. which is the fifth root of 24 over 2. This is kind of a difficult concept. I won't test you over it for a little while. We'll do some more examples like it before we do test, but I want you to at least be exposed to it. And there are 3 problems in Delta Math like it.